So this was a pop quiz 3 related to group 2 and group 7 topic. The first question is magnesium ethene dioate, which is given MgC2O4, decomposes on gentle heating to form magnesium carbonate and carbon monoxide. State why the thermal decomposition of magnesium ethane diode should carried out in a fume cupboard. Look, whenever we have the toxic gases are there, then it should always be done in a fume cupboard. So simple answer is we have a carbon monoxide which is toxic. So toxic gases should be carried out in a fume cupboard. After heating 6 grams of a magnesium ethane diode um, after heating 6 grams of a sample of magnesium ethane diode for 3 minutes, the decomposition was 70% complete. Calculate the total mass of a solid magnesium that remains. So for this, we need the equation as well. For magnesium ethane diode, so 70% has decomposed. So first we'll find the total mass of a magnesium ethane diode, and using a ratio, we work out how much magnesium carbonate will be there, and only 70% will be decomposed of the total. So we'll just take the ratio of the mass. So 6 grams of a sample. So when we work out the total mass of a magnesium ethane diode, the molar mass, it will be 112.3. On the mass of magnesium carbonate, magnesium is 24, carbon is 12, and oxygen is 16. So the total mass, when we add them, it will be 84.3. So that's the ratio of the mass. Only out of 6, 70% has decomposed. So what is the 70% of 6? So 7 multiplied by 6, 42, 4,200, 420 divided by, so it will be 4.2. 70% will be 4. So 4.2 has decomposed. So if 4.2 has decomposed, how much magnesium carbonate will be formed? So we take a ratio. So 112 give 84.3. So 4.2 will give X. So it will be, ratio will be 4.2 into 112.3 divided by 84.3. That will be 3.14. So 3.14 gram, this is 3.14 gram of magnesium carbonate. And this is the mass which is decomposed. How much left? Like this is the mass of a magnesium ethane diode, which is decomposed. So how much we are left with? Originally it was 6. So 6 minus 4.2, it will be 1.8. So 1.8 gram of unreacted or the reactant will be there, and 3.15 grams of a product will be there. But the question is, what is the total mass of a solid? Carbon monoxide is a gas. So what is the total mass of a solid? It is the unreacted reactant and the formed product. So when we add them, 4.95 gram will be there. That is the total mass. Because in the question, we need the total mass of a solid mixture which is remain. So how we work out the total mass of a solid mixture remain? The total mass of this compound is 112, the molecular mass. And magnesium carbonate is 84.3. If 70% has decomposed, means how much decomposed out of 6? 4.2 has decomposed. So 4 decompose, how much magnesium carbonate it will produce? When you take a ratio, so you will get, it will produce 3.15 grams of magnesium carbonate. So this will be the product, or the solid product which will form. Carbon monoxide is a gas which will escape. And how much reactant will be left? Originally, we were using 6 grams of the reactant, but out of 6 grams, 4.2 has decomposed according to a question, 70%. So how much we are left with? So 6 minus 4.2, that is equals to 1.8. So 1.8 gram of the unreacted reactant and 3.15 gram for the formed product. but we need the total. So for total unreacted reactant and the formed product, when we add them, we get the total mass of a solid that is left at the end. Is it clear? Why we are taking 3.1 grams? Because in the question, we need the total mass of a solid mixture. So there is unreacted, this substance, originally it was 6 grams, but out of 6, 4.2 has reacted because 70% has decomposed. So how much we are left? We are left with 1.8 grams. And when this magnesium ethane diode will decompose, if 4.2 grams will decompose, how much magnesium carbonate it will produce? It will produce 3.15 grams of magnesium carbonate. So 1.8, the left reactant, and 3.15 is a formed product, and we need the total mass. That's why we add them. So unreacted reactant and the formed product. Magnesium carbonate undergo a thermal decomposition at a higher temperature than magnesium ethane diode. Explain the trend in thermal decomposition of group 2. Is it clear, the last question about the thermal decomposition? So the last part, magnesium carbonate to magnesium oxide and carbon dioxide. Explain the trend in thermal decomposition. So what is a trend in the thermal decomposition as we go? The thermal decomposition as we go down the group, the thermal decomposition, the size of the ion, like we have magnesium carbonate is there. We have calcium carbonate is there. We have barium carbonate, strontium carbonate. So as we go down the group, the size of the positive ion increases. When the size of the positive, so thermal decomposition temperature, as we go down the group, it increases. Why it increases? Like it become more stable as we go down the group. Because when we have a positive ion which is smaller, it causes a greater distortion to the negative ion. The carbonate ion distortion will be more. But as the size of the positive ion increases, as the size of the positive ion increase, what will happen? The distortion will be less. So magnesium, as we go down the group, the size of the cation increases. The positive ion size will increase. As the positive ion size will increase, what will happen? The distortion to the negative ion will be less. Like at the top, it will be greater distortion, but at the bottom, it will be less distortion. So as a result of a greater distortion, it can easily decompose. Where small distortion, it will be difficult to decompose. So if more polarization, easy to decompose, less polarization, difficult to decompose. So first thing you will mention as we go down the group, the size of the positive ion increases. So the polarization or the distortion decrease. So it will become easy to decompose the carbonate. At the top of the group, it will be easy to decompose as compared to that, the bottom of the group.